geometry. We are busy with our first theorem. Today we're going to look at the second theorem. The first theorem of geometry in grade 12 is about when you have a little triangle and there's one line parallel. Now I'm going to draw it this way this time. If there's one line drawn inside of the triangle, it could even be outside, but we'll get to that. That you've got parallel to the third side. Then something happens. Now I've drawn it so that it actually looks like those lengths are the same, but they're not. The main thing about this is, if those two lines are parallel, then these AD to DB will be the same ratio as CE to EP, or any scenario. BE to EC, BD to DA, AD to AB, CE to C. Are you following those little pictures there? Yes. So that's theorem 1. And what does the theorem say? Line parallel to one side of a triangle will divide the other two sides in the same proportion or in the same ratio, proportionally. So for this particular question, when you see it, you don't even see a circle. We're going to get to circles. All the grade 11 theorems 1, 2, 3 up to 9 also can come into play together with this. But the main thing that you're looking for is a triangle and parallel lines. And then also remember, sometimes we can ask you to prove the parallel lines. It doesn't have to be there. Then if I say, this is 2 to 4 and this is 3 to 6, what does it mean? The lines have to be parallel. That's the converse. If they are the same ratio, in proportion to each other, the lines will be parallel. Are you with me? So now have a look at this sum. Is there that scenario somewhere of parallel lines?
Yes.
Where? Look at the parallel lines, right? How many triangles, possible triangles that have that scenario? And name them. Triangle? AB, AEG, yes. And now here? ABC. ABC is just a triangle. You don't have this scenario with two lines that are parallel to each other. Sit still.
AFG.
So I've got AE, G and CG. Are you seeing it?
Oh.
And color helps you. Now what might have thrown you is these parallel lines. Because the lines are parallel if it's there as well. But there's no little arrow there, but it's a straight line, so it'll still be parallel to each other. So you can look at the triangles and maybe make the one another color to be able to see it better. Do you see that black situation there? See it better now? And what was the other one? Let's make it
Green.
if the green wants to work today. Nope, doesn't. And also the red doesn't really want to work. Nope, doesn't want to work with me. Okay, so let's just have a look at, you're following my drift, the purple colored in triangle. So now, what's been given on that sketch is not enough, and I don't even know what the question is yet. Question is, find me the ratio between BD and DF. So it's definitely in this black triangle.
Yes.
That ratio in the black triangle. But I've got nothing unless I read what the question said. Question said that AE to AF, AE to AF is 3 to 8. Meaning that the ratio between their lengths is 3 to 8. Does that mean it's 3 centimeters and 8 centimeters? No, so be careful of saying that. So if it's 3 to 8, it means that this whole thing here is 3. Doesn't mean 1.5, 1.5. Nobody said that. Whole thing is 3. Then this complete thing up to here is then 8. What does that implicate? Are you with me? They didn't say that. I made the deduction. It's logical. If this is 3 to 8, so the complete one is 8, that's already 3. But is it length? No. It's just ratio. So I need to tell them that I know that this was given to me, and that is why that would be equal to 5. So it was given to me. Okay, maybe let's finish it up first so you can see where we're aiming for this. How does that help me? And also that wasn't the only thing given, because that's not enough information. There's something more given. The fact that 2 times AB is the same as BG. To me, this looks like kind of like almost the same. Don't you agree? Remember, sketches aren't according to scale. So if this is this twice this one?
Yes.
It says 2 times AB would be the same as this one. So this is the shorter one. So if you have to look at ratio, this will be a 2 to 1 ratio. Because if you time that one with 2, it'll be the same. Are you with me? Because there you could make your first mistake. But now remember again, it's not lengths. So what I'm trying to get you to work with is saying that, for instance, this is 3, x and 5, x. And still, maybe we shouldn't have done that just now. It's going to work out automatically, luckily for us. And then this would be 1, y. Because remember, it could be something like 10 to 20, then the y was 10. This could have been 300 to 500, then the x would have been 100. But it's still in a ratio of 3 to 5, a ratio of 1 to 2. Okay, so we can't make them the same. But have a look now at what we have. We know that we're aiming for the black triangle, because this is the question. But I can't get this question unless I know what that little PC there is. If I knew that this was 4 to 5, then this would be 4 to 5. But I don't know. How could I get there? Because of this triangle being the 1 and the 2, they won't give you information that you don't need. So if this is 1 to 2 that you had to go figure out for yourself, then what would this be? Okay, so 1 to 2, 1 to 2. Are you with me? Now, fortunately for us, this was 3x, so that's so nice to break it up into 1 to 2. What would that then be? 1x. And this would be 2x. So what I was going to say about it is, say for instance that was 6x. How would you break that up into 1 to 2? So it would be 2x to 4x. So for another scenario, if it's necessary, and you know that the whole thing was 6, and it had to be in the ratio 1 to 2, are you getting what I'm saying? So that we can get those values in ratio to each other, in comparison to one another. So what I'm saying is we were lucky in this sum that we had 3x. Because to take 3x and break it up into 1 to 2 would be easy, like namely 1x and 2x. But careful, x, not another thing now, because this was x broken up into 1 to 2, so it stays into terms of x. So that would mean that if that is then 2 to 5, I'm done with my sum and I haven't written nothing. So what would the answer then be for DD to DF? This to this. In which triangle am I? FCB or BCF, whatever you'd like to call it. See the 2 to 5? See the black parallel lines? So that'll be 2 to 5 again. 2 and 5 what? Something else. So if you wanted to say something, you could say like A, that's fine. If it's on the sketch, you don't really have to say the x's and the y's, but it helps you a lot. And you're going to use it in your formula now. But the answer here is going to be 2 to 5. Because we don't say 5a and 2a there. It's a ratio of 2 to 5. It could have been 40 centimeters. That means I'm timing with 20. So this would be 100. 40 to 100, still 2 to 5. Lengths is not the same as the ratio. Okay. Okay, I've got full marks. No, I've got no marks. Maybe if that's somewhere in your sum, I would give you 1 mark out of 8. So where did we start in the sum?
We started by the x.
By the x's, and where did I get the 5x from?
You got it from the given.
So you've got to tell them that. You've got to tell them that AE to AF, and you can write it this way, you can write it as a fraction, was equal to 3 to 8, which was given. Okay, well that doesn't give me any marks, but that is why I know that EF is equal to
5.
So I'm going to write all the x's down there so that they know where my things come from on my sketch. So if it's 3 and 8, Let me write it to them so that they can also say 3x and 8x, so that they better know where my 5x came from. Not everybody does it with these x's, but I'm telling you now it's the best possible technique. Okay. That helped me then to know that this was 5, but I was wondering about this. Where does this come from?
You broke down the
From this. And here you also got to say that A, B to B, G was equal to 1, 2. Where does that come from? Because it wasn't given like that. They told me that this one is times 2 will be equal to this one. So I'm going to tell them. I've sorted it out for myself. From this that's been given, I never said it, but if I said this has been given, therefore I can see where the 1s and the 2s come from. And with me, explain to the marker what you're trying to show them, especially if you've got something funky doing something else. Explain to them. Was there any reasons for this? They were all given and logically sorted out. There's no reason for that. But then I went to the theorem. After knowing that this is 1y and 2y, I said
this
1x and 2x.
x.
So in which triangle? In the purple triangle, A, E, G, the one that's been colored in. What happened there? So in the purple triangle, I've got these purple lines, E, G, and C, B, that were parallel, that was given. Normally not worth a mark. But if you're busy with these sums, you always want to say, I've got the lines are parallel, so that's why I can get the sides are in proportion to each other. So always write this, whether it's going to be worth a mark or not, is up for debate. But from that parallelness, it's going to come that A, C to C, E is going to be the same as A, B to B, G. Do you see the story? Top over bottom is top over bottom with the parallel lines in between. So, and the reason for that, and then that would be 1 over 2, right? Which I'm going to write there as 1x and 2x. X. I know that this was actually 1y over 2y, but it still says a half. Because the y's cancel out, the x's cancel out. It's just for them to see where my magical 1x and 2x come from. Okay, and the reason, first time, line parallel to one side of a triangle will divide the other two sides in the same proportion. Then I need to go to the other triangle and say, in the black triangle, and the black triangle was FCB, or which way did you want to write it? FCB. We're also going to have the lines are parallel. Do I really need to write again that ED was parallel to CB? I don't have to write that again. So I need to say that the question was that BD to DF will then be the same as, and I'm keeping it the same as what that was. So that BD to DF would be the same as. Now I'm writing it in this form. It doesn't matter if I write it in fraction form or in ratio form. So if they ask to me in the ratio form, please answer them in the ratio form. So BD to DF, BD to DF would be the same as EC to CF, which you also don't have to really say EC to CF, EC to EF, sorry, which is equal to 2 to 5. And 2 to 5 is not the same as 5 to 2. You've got to have the right one on the right place. And again, this is because of line parallel to one side of a triangle. That was theorem 1 and the work that we've done there. Now we're going to look at theorem 2. Theorem 2 is on similar triangles, and this is taking you back to grade 9. You did this in grade 9. You know that similar triangles are, now let's quickly recap. What is the difference between triangles that are similar and triangles that are congruent? If they are congruent, exactly the same. You can cut the one out and place it exactly on the other one. So all three sides, all three angles, exactly the same. Reasons for congruency, let's see if you're clever.
Side,
three sides, three sides. Side angle sides means something. It's two sides and the included, and it can't be any two sides at any angle. It's got to be two sides with the angle in between them, And in the other triangle, also those same two lengths and the same angle in between them. Two sides and an included angle. The third one is angle,
Side.
Side is always a side. Angle, side also means two angles corresponding with each other and the side. So it can't be anywhere. Again, if you have a triangle and another triangle with this angle and this angle, and I'm calling it, this one is the same length as which one should it be there? EF. How come? Because it's proportionally in the same corresponding places. It has to be this one. Next to the little crossy across from the little circle. Next to the little crossy across from the circle. It has to be on the same place. Two sides and two angles and a corresponding side. Then the third one is only for right angle triangles, which means the two sides, the hypotenuse side must be the same. They've both got to have a 90-degree angle and any other side. So it can be hypotenuse side, 90-degree angle, and another side, which order you ever want to say that, it doesn't matter. 90-degree angle, hypotenuse side, and another side, however. But can this still have two sides included angle? Even if it is a right angle triangle. If I gave you this, what would be the reason for congruency? No, it's not. I'm sorry. Now it is. Side angle side. Side angle side. So all the reasons can go for a right angle triangle, but the right angle reason is only applicable in a right angle triangle. Guys, that's enough revision, you should know that. Okay, now I'm getting to the fact that these two triangles would be
congruent.
Whatever, X, Y, Z, doesn't matter. What does that mean?
Congruent.
Similar. That is similar. These which we were talking about, the 4 rules were of congruence. So don't make this the wrong symbol for the wrong thing. So now we're going to be working with similar triangles. What is the only reason for two triangles to be similar? Side, angle, side, angle, side. All the angles are the same. So the only reason for similar triangles is that's it. Nothing else. Which means you can have a small little triangle and a huge triangle, but they have the same angles. Because the sum of the angles have to add up to 180. Whether it's a small triangle or a huge triangle, add up to 180. If the angles are the same, that makes the triangles similar to each other. Okay, so don't forget about congruency because you can use it when available. Now the theorem says, what you've been doing in grade 9, that if two triangles are similar, then I will be able to say something about their ratios. What is grade 12 geometry about? Ratio, proportion, similarity. And even in the similarity, we're going to have ratios that are equal to each other. You will be reminded of what you did in grade 9 when you said, then AB over DE would be the same as AB over DE would be the same as. So it's following a pattern here again. And AC over DF. Depending on what you need. And the reason for that is like abbreviation. You don't have to say similar triangles, it's just similar triangles like that. And that is theorem 2 for grade 12. But you've done it a long time ago. But you're just going to do a little bit worse sums now. But in essence, it's not too bad. It can get worse, but it's not too bad. Alright, so if the triangles are similar, but am I right in saying A, B, C, D, E, F? Do we always do this alphabetically? No. You've got to make sure that those angles are in the same order. So A has the same value as D, and B crossy with E. And then why will C be equal to F?
Because they're blank.
Because it's the two blank ones, but those two blank ones always mean that they're the same. This and this and this all the same. Okay, why are they the same? It's the third one. the sum of the angles have to add up to 180. So the third one, after 2 being the same, will have to be the same. And that's something you're going to be using all the time. So let's get to an example. I'm going to give you these two triangles and I'm going to say find Z. Is it theorem 1 that we've just done? Where's the parallel lines?
None.
Then you've got to start thinking, okay, there's no circles either. So I've got to look for similar triangles. Are you with me? I'm teaching you how to think this through. In circles, you had to go think 9 theorems. In triangles, and the triangles can be in circles as well, we're getting there. But if it's triangles and I'm asking for lengths of sides, what am I working out with this? If there was a length that was unknown. So I will be able to work it out. Okay, but I have no angles. Oopsie. No angles. The question said to me, see, I will just read the question first. They say, RAM, because this is crucial, I couldn't do the sum. Not enough information. Why would those angles be the same? Give me one angle that is the same.
Angles at A.
The angles at A, they don't even have names shown. But why are they equal?
Vertically opposite.
Back in grade 8, right? Vertically opposite angles. But the other two, ma'am, aren't they alternate angles? No, they're not. There's no parallel lines. You can't just assume things, even though they look the same. Looks can be deceiving. They would be alternate angles if the lines were given parallel, and they're not. But what was given was RAM is what? Similar to, and the sum said that. The sum gave it to me. So what are they telling me?
Proof.
R
is
equal to
X. Okay.
Because they said so. If it's given, it means that the corresponding A and D, B is equal to E, C is equal to F. Guys, it's very basic. So because it's been given, you know that angles are all equal to each other. Do I now have to go prove it? If it's given to me, why would I want to go prove it? If I have to prove it, I'll have to say, those angles are equal given, those angles are equal because of whatever reason, since we're inside of a triangle, maybe bow tie, what, to get the stuff equal to each other. But if the angles are equal, given to me, that is similar to each other, I don't have to prove that. If this has now been given, because this is definitely not alphabetically, it's given for a reason, to tell me that R is equal to
X.
I'm not going to need it, but it is so that R is equal to X. And that A is equal to A. A and A.
Oh,
yes. It's A1 and 2. They're the vertically opposite ones that we need. And then obviously M and E, the last ones will be equal because they have to add up to 180. But I'm not doing that. They gave it to me. If you're so lucky that they give something like this to you, what do you write? The first thing is, all right,
Is it
over X, A? AM,
Okay.
AE, you can do this a million times.
RX. Oh my gosh.
Okay, first two, last two, first, and last. Are you getting that? And the reason for that is?
Similar triangles.
You are doing the grade 12. Guys, it feels so silly, easy. This is the grade 12 second theorem. If you are given or proven or whatever, and it's similar triangles, then you can say this. How does it help me in the sum? That is really a grade 9 sum. If I want to find Z, where is Z? Z is MR. So MR is there at the top, is my Z. My AR is equal to 4. That's over here. My XA is equal to 3. That's over there. Are you with me? And XE was equal to 8. And that's it. So what happened to this poor thing?
It goes away.
Nothing. You're not using it. You have to choose which ones have enough information to work with. So there's one possible equation, another possible equation, and this possible equation. And because of the stuff that was given to me, that's the obvious one I'm going to use, and I'm done with my sum just about. Because those two have to be equal because of similar triangles. And please tell me, what is Z? Can I just see it? Not in this case. You're going to have to say Z is equal to, times it away, what's it? You're most probably going to have it in a decimal answer. Are you with me? Because we're timing the 8 to the other side. How easy is this? Very nice. Theorem number 2. I'm giving you a homework sum to do for me, please. And that is number 4 on page 288. For next time you have geometry.